Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is a part 6. Just wait for the cow to appear. And let's get started. So what is this? We're going to be using the reset switch, master clear. Call it what you like, but it resets the chip. Please like and subscribe to this video. That is really important, and subscribe to the channel. Very grateful. So using the reset switch, let's get straight into it. I am using a PIC-Dem Plus demonstration board. It looks like this. I'm using bits, we've already looked at the potentiometer on 0.6 there. Number 7 is what we're using now. Push 3 button switches for external stimulus and reset. So the reset comes from that name. 4 LEDs, and we're going to use those interactively, those number 6 and number 9 switches and the LEDs. So mine looks like this. This is my board, 2010. This is how I left it yesterday. We've got some LEDs at the top here and some 3 switches down the bottom. Reset, it's even got reset written on it, which is fantastic. So this is the circuit, the schematic from the PDF on this board. Very useful because it's got a reference architecture. So what does the schematic look like for this particular part? Looks like this. Bring up my pen. We have the master clear on the chip. It is connected via a current limiting resistor. It then goes up to a switch S1 and it's pulled high to 5 volts. So when I push it, push the S1 down, the circuit will go to ground and the chip will reset. Or it can be an input. So it can be either, but that's the circuit. Quite a simple circuit, but it needs to be like that to work properly. So let's have a look. Using the reset as an input or master clear. This confused me many years ago. You have a pin. On this one, it's called RE3, and it's a multifunctional pin on certain PICs, on certain PIC microcontrollers. On the older ones, you couldn't do this, but that's why it's on certain PIC microcontrollers. It can either be a digital input or a master clear, like the reset signal. And whenever you program it, you actually do clear that master. You do clear that reset, and but we can use an input. And the way you do that is through configuration. And that configuration control is via what's called the master clear MCRLE register. And you can set it to 2 values on this chip. EXTMCLR, which is the X, so you clear it, and then it's a reset switch, and INTMCLR, which makes it a digital exit as a digital input. So this has design implications. If you want to reset the chip by pushing some button, this is the button to use. Don't use it as an input. And if you use internal master clear, you can use it as an input for button detection. 2 caveats on this, or a caveat on this. If you are using low voltage programming, you can only use it as a master clear. That's just the way it is. So this, I'm using 5 volts. I'm using a PIC2 program. It works great. Okay, so you've got this extra input. So what we're going to do is we're going to use 2 parts, part 1 and part 2, use it as an input, then use it as a reset. And how I'm going to do that is by initializing the chip, flashing LED. It's actually LEDs, should be an S there. And we'll do something forever. And if the reset button has been pushed, if it's been pushed, we'll set the state of the LED. And that's one test. And as an input, that'd be great. But when it's a reset, literally, I'll show you what happens. Point out, clear that. How do I clear my pointers? it will come, it will do the, if it's a reset, it will do it forever. But the moment I push the reset button, it will just come back into here. Oh dear, big change. And we'll see that. And we can see that by showing you the LEDs. So a couple of things we're going to look at, something called PIC18FxxQ35. Look at some sample code. Okay. So let's get into some code, GC Studio. I still haven't updated my system. So we're going to see the update start here. Look, downloaded the latest update. I'm just going to escape from that for a second. My machine is up to date, by the way. Okay, let me reassure you. Okay. Where's it gone? GC Studio's down here. There you go. Zoom in on that desktop. Great. I'm just going to take the 18F folder, or I can do it long ways. I can say which board is it? It's the vendor board, microchip 2010 18F. Select that folder. Debounce the switch is where we left it yesterday. Control. Let's get rid of this one. Get rid of this one. And then open up 080 using the reset switch as an input. So I'm inside it now. I can Control B that to get rid of that menu on the left hand side. So what's going to be different in here? Let's have a look what's changed. That's the same. Specifies the chip, and option explicit which means I have to define my variables. Just a little bit coffee. Then I am using something called hash config. MCLRE equals off. What a problem. Because how would you know what that syntax is? And there are lots of different config options. So let's have a look how you can understand what they are in GCBASIC. From the IDE, press function key F4, type in PIC, PIC-info, all one word, PIC-info. Oh, there you go, PIC-info. PIC-info user. Ooh, let's go into that and have a look. It's opening up a little tool, and here it is. I will zoom in on that desktop so we can see it. There we go. Let me just get rid of the code at the background because that's a little bit distracting. Okay, good. Look, you can pick all the PICs, and there's one for AVR, by the way, in AVR info, but we're just looking at PICs. So I can type in the name of the PIC I want, 18F46Q35, and it comes up and it populates it. It populates at the top. If you have a look at the top, it says Q35. If it doesn't show it, it means that we don't support it. In here, you can get to various different tools, PPS tool, etc. But I'll come on to that in the next video. You can also look at this, configuration options. These are all the config options for this chip. Those with a star next to them are the defaults that we actually include. They're the defaults. So if you want to know, oh, what's the default? Because I didn't put it in, well, they're put in automatically for you. And it says, for this particular one that we're looking for, master clear, internal master clear. And one of my options in here, I've got two options, external, EXT, or INT, internal. Oh. And what I can actually do is I can copy that config and I can paste that back into my code. So I copied it there. If I go back into my IDE, I can actually just paste it in here. But those are all the defaults. Oh, you can't see that. Let me just change that. I just pasted them in there. Control Z, Control V. Look, there we go. So this is where we got it from. Now, that's interesting. I think that if you put it to off, we should update the documentation here. Copy, Control Z. I think we should do it properly. On and off also work, by the way. Okay. All right. Okay, let's see what the rest of the code is. No change to all these constants, and then I've actually got a constant called reset button on RE3 as an input. You can't set it as an output. You can try it, but it won't work. Okay. All right, what I'm going to do is flash the LED port. I knew there was a reason for that constant. Repeat, we're going to flash it 20 times, because if we then see it flash 20 times, we know the chip is reset. And then we got a bit of a loop here, and it says if you press the reset button, set one in LED, and if you press switching, which is set to from the previous tutorial, port A4, it will turn the LED on. So look, if I push the reset and it's the internal input, it will just turn another LED on. Let's have a look at that. Make sure the code works. Function key F5. Go to desk cam. And what we should see are these LEDs flash 20 times. And if I push the reset button, I get LED RB2 come on, which is second on the left. If I push A4 up, I get the other LED. Hey, that's a clever look. So that's an input because it's reacting to that input. Why don't we change the source to the external option here? And on and off also work here, by the way. I was just talking to myself there. Function key F5. Just programming it. It's done it. Saw it flash, did we? Did we see it flash? I didn't see it flash. I'm just going to cut the power. Oh, there you go. Perfect. It did flash. RA4, that's the right hand LED. Look. And now if I push the reset, it flashes 20 times, which is actually 10 times because it's on and off 10 times, and then on 10 times. So I push the reset like that. It's reset the chip. Okay, it's so simple. But I can take the code, as I showed you. Zoom in. I can use the code direct from PIC-info. And what else is in PIC-info is tremendous amount of information. There's all the chip information that we've defined. This comes from the data sheets and other resources. This is the chip data, which describes the chip to the compiler. It says things like the program size, the EEPROM, the RAM, what family it is, how you set up 31K support, how many UARTs it's got, what type of pulse width modulation it's got, whether it's got self-write capabilities, what the stack numbers are, and these are all exposed to you via whatever it says in here. Look, if you want to know how much program memory it's got, later on you can just use chip words, and it's just a number, it's just a constant you can access. And so look, if you want to know how many UARTs they've got, just use chip USART. The maximum frequency is exposed as max frequency. So that tells you that this is the configuration options that you'll be able to support on the internal oscillator, 64 through to 0.125 plus 31K. They're all valid. Very useful tool. In terms of options, these are all the options that you can have for the configs, which we were looking at previously. So if you look master clear, those are the those are the two options that we were displayed in the drop down. This is a list of all the registers, and you can just type to your heart. You can just say, "Oh, does a register port AF exist?" No, it doesn't. Does A exist? Yes, it does. B, C, D? Oh, it does. E, F, no. G, got port W, which is interesting. I'll explain that later. These are the number of bits, and bits are all the bits of all the registers. So there's quite a lot of them, and you can just validate that they exist. and this is what GCBASIC recognizes as them as. They're all unique, and then a series of interrupts, which we will look at later on. All the interrupts are all in here with all their enable bits and their event bits are all pulled out for you. Very useful tool. But what we wanted to look at was this code here, which is how you put a config in here. You've also seen that we can paste config in, therefore we can change the configuration. And that is then exposed inside of the assembler, which is then compiled. And so if we have a quick look inside the assembler by pushing function key F4, typing the word open assemble asm, it shows you in here the config statements that have been put in for you automatically. Part of the automatic setup, part of the ethos of GCBASIC was to make it easier to get going. And here we can see that that one is external master clear and it's got it directly from here. So if I put that back to INT, that's how I want to leave it. Just compile it up. We'll just look at it in here and it's already changed it to the internal master clear, which is fantastic. Okay. Inside of the assembly, there's a lot of other useful information that we'll have a look at in the future. So as a recap, this is the default. So the default for this master clear would typically be the internal master clear, but if you want to go and check in PIC-info. If it has a little star against it, then you know that's its default. So really simple piece of code, and I think we'll call that a demonstration capability wrap in terms of what we're looking at. Now we are going to pull that all together in the next video, which is using the switch, using the ADC, making the LEDs flash in sequence with reverse. So we're going to pull it all together and go show you the demonstration which Microchip have always put on these types of boards when they ship them out, because in reality it's testing a lot of capabilities and it's showing you how to do things inside the chip. It's a very useful tutorial. And with that, I'll go to slide number 2. It's a wrap.